right, we're back with more 1.5. So we're talking about example 3, and we're going to talk about some limits where your answer is going to be infinite. So let's start with the intuitive way of doing, or the Algebra 2 sort of way of doing this, and then we can talk about the textbook official way of doing this, and then after all that, we'll talk lastly about how we can do this sort of logicking with infinity. Okay, so when I look at this using the Algebra 2 method, I say, oh look, this degree, 2, is larger than this degree, so I know from this that my answer is going to be a plus or minus infinity. The question is which, okay? I know that there's no horizontal asymptote, so it's definitely going to be infinite. The question is which. The easiest way to see which is to pick a big number, plug it in, and see if I get a positive or negative, because I know the answer is infinite, I just don't know if it's a plus or minus. So if I try something like x equals, doesn't even have to be that big of a number, to be honest. You could probably go ahead and pick 10, right? If you pick 10, you'd get negative 2 times 100 over a 10 plus 1. That is a large negative number over a positive number. Oh, hey, look, this is going to come out negative, right? So I say, cool, look, logically that's a negative infinity. Now, let's say you wanted to do it not using that method. Let's say instead you wanted to do it using the method we discussed where you use the fact that you multiply by 1 over a number. Here's the wild card in this. You don't actually want to pick the biggest power in the entire expression, which would be an x squared. The reason you don't want to do that is if you multiply by 1 over x squared, the top would end up being a negative 2, but the bottom would end up being 2 of these expressions that are both going to be 0. Remember, you can't divide by 0, right? That would be an issue. So essentially what you want to do is you want to pick the biggest power in the denominator. So you already know the answer is going to be infinite because the numerator power is bigger. So you're going to pick the biggest denominator power. Right? If you were to pick the biggest denominator power, right, then what's going to happen is that this would be the limit as x approaches infinity of you would times by 1 over x and 1 over x, okay? So what's going to happen then is you're going to get a negative 2x, because that's what x squared over x would be, on top of a 1, x over x, plus 1 over x. Now when you try to plug in, what's going to happen is you're going to get a negative 2 times an infinity over a 1 plus 0. That's a negative 2 times an infinity, which is definitely a negative infinity, right? Now, there are other logical ways to do it. If you had chosen to multiply by 1 over x squared and 1 over x squared, you might have been able to logically intuit that this is going to land in a negative infinity. I'm not sure, but we'll figure it out. All right, so let's talk about b. Okay, so for b, I can do this one of two ways. One option is to say, hey, look, I see that the numerator degree is bigger than the denominator, so logically, I know that my answer is going to be a positive or negative infinity. The question is which, right? And then I could try it. I could try picking a number, right? I could try picking, and again, you pick x as 10, pick x as 100, pick easy numbers. Oh, sorry, it would be negative 10, right? Negative 10, because I'm going to negative infinity, right? If I try, let's try negative 10. That would be a 3, right, times a negative 10 to the 4th would be a 1 with 4 zeros, right? But it'd be positive because it's to the 4th power, and this would be a 100 minus 5. Well, what I want you to notice is both the top and bottom end up being positive numbers, right? So this thing must come out to be a positive infinity, okay? And you could just write infinity. I'm going to write positive infinity, but you can write infinity, right? So positive infinity. Now, the other way to do that is to do what we did the textbook way, which is pick the largest power of x in the denominator. If I chose to do that, I'd pick the limit as x approaches negative infinity. I would do this 3x to the 4th times that largest denominator power is an x squared, so 1 over x squared. This becomes an x squared over x squared minus a 5 over x squared. So what ends up happening is I get that this is the limit as x approaches negative infinity of a 3x squared over 1 minus 5 over x squared. When I plug in, that's a 3 times a negative infinity squared, which is totally going to come out positive, over a 1. So I get a positive infinity, right? So again, there's a couple different ways to do that, but I think it's easier to look at it intuitively and know that it's going to be a positive or negative infinity and then plug in a large-ish x value in the correct direction. But that's my preference. It doesn't have to be yours. All right, so let me give you a P3 to try. And again, I don't really care which way logically you choose to do this, but let's go ahead and try P3. All right, so when you go ahead and try P3, Let's do the limit as x approaches negative infinity of 4x over x plus 8. And for b, let's do the limit as x approaches, 4x squared, my bad. X approaches infinity of, let's do x cubed over negative 4x plus 2. Cool. All right. So, again, you can either do this with me or you can pause me and try it yourself. So, first I'm going to do it the intuitive way. I notice that my degree 2 is larger than 1. So, once I see that, I say, okay, the answer is plus or minus infinity. The question is just which, right? As I plug in this negative infinity, and I can pick a really large negative value, or again, doesn't even have to be that large, I can pick negative 10. That's going to give me a 400 on the top, positive 400 because the negative 10 squared. And on the bottom, I'm going to get a negative 2, right? So it's a positive on top of a negative. So it's going to come out negative. My answer is that this is going to go to negative infinity, okay? And we'll do the mathy way to do that now. So the other option is to multiply by, look at the biggest power of the denominator x, which is a 1. And the other way to do this is to say, okay, cool, this is the limit as x approaches negative infinity. I'm going to multiply this 4x squared by a 1 over x. I'm going to multiply this x plus 8 by that 1 over x. And I'm going to get that this is the limit as x approaches negative infinity of a 4x on top of a 1 plus 8 over x. Well, when I plug in, that's a 4 times a negative infinity over a 1 plus 0, which is totally a negative infinity, right? Like 4 times negative infinity would be negative infinity, all right? And that's one way to do it, okay? Again, I really don't care how you do it because, to be honest, this is going to be a thing where you really just need to be able to get the answer. You need to be right, and you want to be fairly quick with it. When I go to look at B, same argument. I say, okay, a 3 is a bigger power than 1, so I know ahead of time that my answer is plus or minus infinity. The question is which, right? So I'm going to infinity. I'm going to go ahead and plug in and pick a number. So let's just go ahead and pick x as 10. That would give me a 1,000 on top of a negative 40 plus 2. That's a positive number on top of a negative number, which comes out negative. So my answer is negative infinity. If I want to figure that out in the mathier way of doing it, I would multiply both the top and the bottom by a 1 over x, because that's the biggest power of x in the denominator. So the mathier way to do it, and the way that your textbook does it, is they're going to multiply this x cubed by a 1 over x. They're going to multiply your denominator by that 1 over x, and you're going to get the limit as x approaches infinity of an x squared, because that's what x cubed over x would be, and then a negative 4 plus 2 over x. When you plug in infinity, that's going to be an infinity squared, which would totally come out positive, over a negative 4 plus 0. Well, that's a positive number on top of a negative 4. So that's a negative infinity, right? When you square an infinity, you just get another infinity, but the fact that there's a negative 4 is going to be the difference. All right, cool. So let's now, let's talk about, well, before I talk about logic, we'll save logic for after I do one more, okay. I'm going to go ahead and do a slightly harder example, and I'm going to explain to you how logically I can figure out the answer without actually doing it the mathy way after I've already shown you the mathy way. That's what I think. All right, so let's do the limit. So now so here's when this is going to get harder. So this is harder because it's not going to be rational functions. So what makes it not a rational function is I'm going to throw a root in, and it's going to make it a little bit more difficult to deal with. So let's do the limit as x approaches infinity. We're going to do a 5x squared plus, no, let's do 5x plus 3 over the square root of 4x squared minus 7. Now, I'm going to tell you right now that looking at this, the answer to this is a 5/2. And I'm actually going to do an A and a B. I'm going to give you the exact same one. But to negative infinity. And I'm going to tell you that just by looking at this, the answer is a negative 5 halves. Okay? So this, right, I got this answer by using logic. Okay? Now I'm going to walk you through the mathy way to get this answer, and then we're going to revisit this last thing that I've been talking about in all the other videos that we haven't gotten to yet, which is how you can logic your way through dealing with infinities. But before we do that, we're going to go ahead and do this the mathy way that your book's going to advocate, and you're going to see that the answer is that 5 halves or that negative 5 halves, but it's going to take a little bit of math to figure it out. Okay, so here's the trick. And actually, I kind of cheated and used some algebra 2, but not entirely. Okay, it's this like combination of the logic and algebra 2. So the trick here is that I want to use that same limit thing that the book's been using, right? Where I want to multiply it by the biggest power of the variable that I see, right? Well, the trick is that this power is an x to the first, right? And this power is an x to the squared, but it's an x to the second, but it's x to the second inside the root. So what I want to do is I want to multiply by essentially a 1 over x on top of a 1 over x. I do want to multiply by 1 over x on top of 1 over x. The trick is that I'm going to rewrite this as a square root of 1 over x squared, because that's what it actually is, right? Like it could, if I wanted to multiply it inside the root, I'd have to rewrite this bottom one as a square root of 1 over x squared. So what I'm going to do is I'm going to take this limit as x approaches infinity, and I'm going to multiply this by a 1 over x, and the 1 on the bottom, I'm also multiplying by a 1 over x, but I'm writing it as the square root of 1 over x squared. Now, I can do that because x is positive. So if you took this value, right, so just to be clear, the square root of 1 over x squared is actually equal to the square root of 1 over the square root of x squared, which is actually a 1 over the absolute value of x, right? Because the output of an even root, so the output of a square root is positive. So since you don't know if x is positive or negative, you have to put an absolute value. But here you do know that x is positive because x is approaching a positive infinity, so x has to be positive, meaning that you can go ahead and replace this 1 over x with, with a 1 over the square root of x. Square root of x squared, rather. Okay, so now when I distribute and clean this up, I'm going to get that this is the limit as x approaches infinity of a 5, because it would be 5x over x, plus a 3 over x. And inside the root, when I distribute this into the inside of the root, I'm going to get a 4, because it would be 4x squared over x squared, minus a 7 over x squared. So now, when I go ahead and plug in my infinities, I get that this is a 5 plus 0 over the square root of 4 minus 0. Well, that's a 5 over the square root of 4, which is a 5 halves. As you'll recall, that's the answer I got doing this problem with logic. Now, again, I'm not saying there's anything wrong with doing what the textbook would do. It's the technical, mathy way to do this. But when you see this question, you're going to see it as a one-off question of, do you know the answer or don't you? And so being able to logic through it in your head is going to be super advantageous. But you don't have to. You can do it the mathier way. It's just going to take longer and be more difficult than it would be to just have some prior knowledge. Okay, now let's talk about why this one's a different answer. It's all the same steps. It's the exact same problem, right? But the difference is I'm plugging in a negative number. So x is a negative. Well, here's the problem. The output of a square root has to be positive, right? But I know that 1 over x should be negative. So I am going to multiply this whole thing by 1 over x just like I did. And 1 over x, the problem is that when I rewrite this 1 over x as a square root, I have to write it as a negative square root because this value is a negative number. If x is negative, 1 over x is negative. I can't rewrite 1 over x as the square root of 1 over x squared because that would be a positive. This would be a positive number. So I have to put a minus in front of it. So basically, all of the math is the same except there's a minus in front of this thing. So what that's going to do is when you get to this step here, I'm going to end up with the limit as x approaches negative infinity of a 5 plus 3x, plus 3 over x, But on the inside here, right, because of that, like, because there's this negative, right, because there's this negative in front of the square root, I'm going to have a negative in front of the square root, and my inside is still going to be a 4 minus the 7 over x squared, right? So it's exactly the same, but this negative right here becomes a negative in front, so I get, when I plug in, 5 plus 0 over a negative in front of that same square root, which is how I get 5 over negative 2. Okay? Now, you can also see this if you put them in your calculator, and I'll just show you so that you see, but you wouldn't probably have a calculator in this situation. So if I put in my calculator in parentheses 5x plus 3 divided by the square root of 4x squared minus 7, right? And we'll see if this graph turns out nice or ugly. Okay, so what you'll see is that there is a domain restriction on the graph, so there's nothing in the middle there because you can't plug in stuff that would make the bottom 0 or negative because you can't have a negative inside this even root. But you'll see that both sides of this graph have different horizontal asymptotes. As we go x to negative infinity, that's a negative 5 halves, negative 2.5. And as x goes to positive infinity, that's a positive 2.5. So, again, the logic holds, but I get that it's hard to see this logically, and I'm going to explain how the logic works when we get to the third step of this. But I want us to do a P4, again, where you try to do it the mathy way, and then I'll walk you through the logic of how you can often spot the answer to these things. So let's do a P4 that's going to be similar. So P4, same thing. So for A, let's do the limit as x approaches infinity of, let's do the square root of 3x squared plus x plus 1 over let's do a 4 minus 2x. All right, so, and then we're going to do the same thing in the other direction, right? So we're going to limit as x approaches negative infinity of this root 3x squared plus x plus 1 all over a 4 minus 2x. Okay, now I'm going to go ahead and tell you that using my, so pause me if you want, pause, but now I'm going to walk through P4. So I'm going to tell you that logically, I can tell you right now that this answer is going to be a root 3 over 2 with a negative, and that this answer is going to be a root 3 over 2 with a positive. So this is the answer I got by logic. Hogan logic. Okay. Hogan, that's not how you spell my name, but logic Hogan, that works. Okay, cool. All right, so and then we're going to go ahead and walk through the math of how it would work, and that's totally fine. But yeah, so again, it's really one of these situations where doing this the mathy way is just so totally not worth it. Okay, so same trick, okay? I realize that what I want to do is multiply this whole denominator by a 1 over x and this whole numerator by a 1 over x, but that I'm going to replace this 1 over x by a 1 over the square root of the, or by a square root of the quantity 1 over x squared, okay? And I'm going to do the same trick down here when we get to it. But again, because my x is approaching a negative infinity, I'm going to have to behave slightly differently. So here, since x is positive, see how x is a positive number, limit as x approaches infinity, I'm going to distribute this root 1 over x squared, and this is going to become the square root of 3x squared over x squared, which is just a 3, plus an x over x squared, which is just a 1 over an x, plus a 1 over an x squared. That's all inside the root. And on the bottom, when I distribute this, I'm going to get a 4 over x minus a 2, because it would be 2x over x. When I plug in, I'm now going to get root 3 plus 0 over 0 minus 2, which is root 3 over negative 2, which is totally the answer that I logically predicted. If I do the same thing down here, remember the trick is that if x is negative, so if x is negative, then in order to replace this 1 over x, I have to use the negative square root of 1 over x squared, because 1 over x should be a negative number. Since the square root of 1 over x squared has to net a positive, I need this minus in front to get the right sign. So what I'm going to do is times by the negative square root of 1 over x squared and the 1 over x. Notice that it is exactly the same work as this. There's just a minus sitting out in front. So I'm now going to get that this is the limit as x approaches negative infinity of a minus in front of this 3 plus 1 over x plus 1 over x squared all over a 4 over x minus a 2. So now when I plug in, I get negative root 3 over negative 2, which is how I got a positive root 3 over 2. Okay? Now, we're going to use what's left of this video to talk through the logic of how these limits work, because I can usually look at a limit and predict which way it's going to go, just sort of looking at the logic. Okay, so let's talk logic for a sec. As you approach infinity, so here's my big logic spoiler how I'm able to cheat. So here's my Hogan logic. As x approaches plus or minus infinity, only the leading term matters. You might say, okay, but Hogan, that doesn't make any sense. If x is huge, the other terms totally matter. My argument is that that is not the case. My argument is that if you have, so let's pick a really big x, right? Okay, so let me show you an example, okay? So as an example, let's talk about the limit as x approaches infinity of a 5x squared plus x over a 4x squared plus 3. Okay, here's my logic. Pick a big number. In fact, don't even pick that big of a number. Pick a 10. If you plug in a 10 here, you get 5 times 100 plus 10. Compared to the 500, the 10 is very, very, very small, right? It's still a number, but it's pretty small. Similarly, compared to the 400 you're going to get when you plug the 10 in here, 403, the 3 is very, very small. Okay, now pick a bigger number. Pick a million, okay? 5 times a million squared. That's a 1 with 12 zeros, okay? 5 with 12 zeros is so much bigger than a 1 with 6 zeros, right? 4 with 12 zeros is so much bigger than just the number 3. These numbers aren't going to matter as x values get really, 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 really big. They're just not going to matter. So essentially, the logic with infinities is as the x's get infinitely large or infinitely negative, right? Infinitely large positive or infinitely large negatively, you just really don't have to pay attention to the other terms. You only care about the leading coefficient. So if we use that logic, this is going to jive with the thing I told you was previous knowledge in Algebra 2. Let's pretend these don't exist. Well, if these don't exist, wouldn't these x squareds cancel and I would just get a 5 over 4? Well, that's the correct answer. We've seen that. If the degrees are the same, the leading coefficients are my answer, right? Let's do another example. What if I have one, let's do the limit as x is really, really, really negative, of a 3x plus 1 over a 7x cubed plus 4x minus 3. Great. Okay, my argument is that for ginormous values of x, either positive or negative, only the leading terms matter. If none of this mattered, right? If none of these mattered because they were all chump change compared to the big bucks, wouldn't this behave like a 3 over 7x squared? Which would totally go to 0, right? So it's not a 3, so this is not a 3x over 7x cubed, but this is going to behave like a 3x over a 7x cubed. It's going to behave like the other stuff does not matter, which would be a 3 over a 7x squared, which is totally going to go to 0 because a 3 over something infinitely large would go to 0. And sure enough, that jives with the Algebra 2 stuff that we learned, where if the top degree is smaller than the bottom degree, you end up with a 0. By the same argument, if we look logically at one like this, the limit as x approaches infinity of a 4x cubed minus 8 over a, let's do a negative 7x plus 3, okay? Same logic. If only the leading terms matter, even though this thing is not the same as, so this behaves like a 4x cubed over negative 7x. It behaves like the other terms are too small to matter, which would mean this behaves like a negative 4/7 times an x squared. Well, if you plug in a number to this thing's going to come out positive, this thing's going to come out negative, so this thing is going to negative infinity. because you're plugging in an infinitely large number, and this behaves like a -4/7 times that number squared, right? So it's not mathematically right to say that this thing equals this, because it doesn't. But it's not wrong in your head to say, logically, for large values of x, this thing behaves like this, right? For large values of x, this thing behaves like this, which is just a 5/4. For large values of x, this whole thing behaves like this. So now if we transfer that logic to what I just did with the square roots, let's go back to the limit as x approaches infinity of something like, let's do a 5x squared plus 8 over the square root of 9. Oh, let's do 5x plus 8. 9x squared plus 7x minus 2. Okay, so let's play the same fun game. I'm going to argue, and we'll do both the limit in the positive and negative direction, right? Negative infinity of the same thing. Okay. So this is really similar to the example that I just did with you and made you math through, and I got the answer without doing a lot of work. Okay, so let's play the logic game. For really big values of x, only the leading terms matter. So it's going to behave, so this behaves like a 5x on top of the square root of 9x squared, right? Well, that's the same as a 5x on top of a 3, and then this is the tricky part, right? This has to have a positive output, right? So a 3 times the absolute value of x. Now, the reason that we end up with two different possible answers is because for positive x, okay, so the way this behaves is for positive x, the absolute value of x is just an x. But for negative x, the absolute value of x is the opposite of x, right? We've talked about this. So when I look at this, I say, oh, for positive values, this is going to behave like a 5x over a 3x. So this is going to behave like a 5x over 3x. Oh, hey, the answer is totally 5/3, right? But when I go to do this one, I have to say, wait a second, this is a trap, right? This is going to behave, this behaves like a 5x over the opposite of 3x, meaning this one's going to a negative 5/3. Now, there's another logical way to think about this. If you're having trouble with this whole plus or minus thing and you're like, oh my gosh, I can't remember whether I'm multiplying by a negative or positive, time out. It's not that bad. You ready? Here's the logical part, okay? Let's say that you're like, Hogan, I can't handle this. When do I use a positive? When do I use a negative? Okay, you're plugging in a positive infinity, right? So when you plug a positive infinity into the 5x, aren't you going to get a positive out? And since the output of an even root has to be positive, aren't you going to get a positive? So you're getting a positive number, and it behaves like this 5 over root 9. When you plug in the negative infinity, well, you're plugging in a negative infinity, so the top's going to be a negative number, but the output of an even root always comes out positive, even if you're plugging in that negative squared, so you're going to end up with a negative 5/3. So the way I was able to look at those problems and say, boom, I know the answer, is by saying, hey, all of this static doesn't matter. What matters as I approach infinity is the leading coefficients. You're only allowed to do this cheat when you're approaching infinite values, because when you approach infinity, the smaller terms are irrelevant. It's sort of like if you're like Jeff Bezos and you see $1 on the ground and you're like, nah, bro, not worth my time. I'm a gajillionaire, right? Or Zuckerberg or Gates, and you're just like, nah, bro, I see $100 on the ground, but it's not worth me bending over. That would be a waste of my time. So this stuff is just minor stuff compared to this, which is why you can do this cheat. Again, that's not a mathy thing. Like if you were asked to defend your logic mathematically, I would probably opt for the textbook thing, but most of the time you're not asked to defend your logic. If you were asked to defend your logic, make sure you say things like this behaves like this for large values of x. You can't say this is equal to this because it's not, right? But you can say that it behaves that way for large values of x, and that's not a wrong justification. So anyway, that's my logic and how I'm able to look at these pretty quickly and get answers faster than some other people maybe, and hopefully you can too.